All right, so here's where we left off in the last video. So now we're going to talk about the hardware that's used in both wired and wireless networks. Okay. To function, all networks must include three things. Okay. Remember this, by the way. Remember. Okay, so they need to have, one, a means of connecting the nodes on the network. So that will be either cables or wireless technology. Secondly, they need special hardware devices that allow the nodes to communicate with each other and to send data. Okay, and then finally, they need software that allows the network to run. So these are three network components that every network must include. Okay, so again, a means of connecting nodes to the network, whether that's through cables or whether it's wirelessly. Secondly, you need special hardware devices that allow the nodes to communicate and to send data. And thirdly, you need software that allows the network to run. So you have to have all three of those things. Okay, so this little figure shows you some network components. Okay, here's our transmission media. So this is how the nodes are connected, okay, whether it's wirelessly or wired. In our case here, it's wireless, okay? We're using radio waves. All right. This is the special hardware part of it, router. We also have a network adapter that's inside each node, every single node, okay? This is the hardware, the special hardware that we use in order to have a network. And then this networking software is running on every computing device. So whether it's running on your tablet or your computer, all right, your printer. So this software is running, making sure that everyone can access the network. Excuse me. The network hardware consists of the physical devices needed to create the network. A network adapter is a communications device used to establish a connection with a network. Other devices used to connect you to the internet include analog modems for dial-up connections. Pity the fool, right? Okay. Digital modems for cable or for DSL connections. And then ONTs, or optical network terminals, for fiber optic networks. Okay. Each device that connects to a network must have some type of network adapter. Most PCs come with a built-in Ethernet adapter, also known as an RJ45, hence this right here. Okay. And this adapter just looks like a large phone jack. The cable that's actually used is called either a twisted pair, or Ethernet cable, or Cat5 or Cat6. Okay. So depending on the size of the network you are connecting to, the other end of the cable is going to plug into either a wall jack, a switch, a router, or a modem. So Wi-Fi networks in homes and public places use IEEE 802.11 standards. Okay. That's a homework question. Helpful hint if you're listening to the lectures. Wi-Fi networks use the IEEE 802.11 standards. Okay, and these ensure that equipment that's made by different companies works together. Okay. Most notebooks have built-in wireless adapters. USB wireless adapters are used to connect devices that don't have a built-in adapter. And the Wi-Fi Alliance certifies wireless devices to ensure interoperability. All right. A WLAN, a wireless local area network, is just that, a wireless local area network. So if you see that WLAN, you're going to know, okay, that's a wireless local area network. Okay. We also have ad hoc networks, and these occur when two wireless devices connect to each other directly. Okay. In infrastructure wireless networks, devices connect through wireless access points. Right. Additional network hardware includes a modem. Okay, that would be for your traditional dial-up connection. A digital modem, so if you're using cable or DSL internet. Okay. An ONT, which is an optical network terminal. Okay, that's if you're running fiber, like fiber optic network. And then a router connects 2 or more networks, while a switch connects multiple devices within a local area network. Okay, so like your home router connects 2 networks. It connects your home network to the internet. Okay, so that's a nice, easy way to think about it. Here's a figure you can find in your book. These are just some devices commonly found on a home network. So we have a notebook here with Wi-Fi connection, another notebook with Wi-Fi connection. Here we have a wireless printer, which is shared amongst devices in this home. Okay. Video game consoles connected to the switch. So this stuff is actually wired, you can see. Okay, here's your video game consoles all connected, wired into this network switch. The switch is also wired, connected by a cable to the router, which has both wireless access point and Ethernet ports. So this is what's plugging in here is an Ethernet port. They have their desktop here with an Ethernet connection, so that means you can see it's connected, it's wired connection. Okay. This could be your optical network terminal, and this would be like the fiber connection to the home, or your cable or your DSL. All right. So to set up a wireless network, you need something called a WAP, and that stands for Wireless Access Point. Okay. What this does is it allows wireless devices to join a network, so pretty much like a switch, right? A firewall can be both hardware and software that blocks unauthorized access to a network. Okay, you can have both a software firewall and a hardware firewall. You can have them running at the same time without having any problems. So, another helpful hint for you. One network can support nodes with both wireless and wired connections. Most people use wireless connections for portable devices like your laptops, your tablets, stuff like that. But a lot of the devices that are connected to your network, like printers and TVs, they usually tend to stay in one location. So you're not often moving around your big smart TV or your big printer. So if you hook them up to a wired connection, if you're able to reach your router and hook them up with a wire, that lets you take advantage of the faster throughput that's achieved by wired connectivity. Wireless networks generally have decreased throughput compared with that of wired networks. Okay, and don't forget, throughput, we discussed this earlier, throughput is the actual speed at which the data transfer rates are occurring within your network. Okay, that's what your throughput is. So why do wireless networks have decreased throughput? There could be lots of different answers, but here's some common reasons why. First of all, wireless signals are more susceptible to interference from magnetic and electrical sources. Okay. Other wireless networks can interfere with the signals on your network. So, a good example is if you're in an apartment building, especially like the newer apartments that have really thin walls. Okay, that your neighbor's wireless connection could be interfering with your wireless connection. Certain building materials, so especially concrete and cinder block, and also metal, can really decrease throughput. So like never put your router on top of your refrigerator or anything metal. And if you can, try and keep it away from, being right by your cinder block wall or a big piece of concrete. Okay, because that can really decrease the throughput. Remember, these are radio waves, so they're very susceptible to interference. Throughput also varies depending on the distance between your networking equipment. So, where's your router? where are you with your device in your house? Are you really far away from your router? Then that's probably going to affect your signal. And you'll note the signal. You'll go from having like your full 5 little rainbow symbols to like having 2 or 1 as you get farther away from your router. Okay. And finally, wireless networks usually use specially coded signals to kind of help protect the data, whereas wired connections don't protect their signals. And so this process of coding signals can slightly decrease throughput, although once it's been coded, the data travels at usual speeds, so it doesn't interfere too much. Okay, so let's talk about network software and protocols used in both wired and wireless networks. There's no special software required to create a simple peer-to-peer network. Your modern desktop operating systems have networking capabilities built right in. Okay, beautiful, right? Oh my gosh, and I apologize for that awful picture. Both client software and server software are needed on a client-server network. So if you're running client-server, you're going to have those 2 different types of software. The client software makes requests, and then the server software fulfills those requests. All right. Protocols define the rules for communication between devices. The rules define how data is formatted, transmitted, received, and acknowledged. Important protocols include TCP, IP, HTTP, FTP, POP, DHCP, and DNS. Okay. Without protocols, devices could be physically connected and still be unable to communicate. All right, so protocols are very important. And TCP/IP is the protocol stack that runs on the internet. So that's a combination of transmission control protocol and internet protocol. Okay, and then here you go. I just gave you a bunch of IP, FTP, HTTP. Here's what they stand for: Post Office Protocol. Okay, you'll see that sometimes in your email. Okay. How to protect your network. So, the very same importance that you place on protecting your house, your home, should be used with network security. It's very important. The first layer of defense is a hardware-based firewall. Okay? This firewall examines the data packets as they enter or leave your network, and it denies access to traffic based on rules set by the network administrator. Okay, so here this guy drawing you a little actual like hardware firewall. Obviously it's not like a brick wall built in your house. Okay, just to get that clear. Here's all these desktops and laptops getting their data through this switch here. This is your firewall, and here's your local area network. Here's your wide area network, which is of course the internet. So this firewall determines, yeah, okay, we'll let this information go through. Yes, we'll let this information come out this way. Or it'll say, you know what, nope, we're going to stop that right there. We don't want that coming through on our network. Okay. And in a business, your firewall is actually a standalone device. Okay. So let me go back. That's layer 1 that we call the fence. So I always forget to mention that, yes, this is a layer. The first layer is called the fence. Layer 2 consists of what we call door locks. Okay. So in a network, the second layer, door locks, are represented by the network configuration, determining what is shared and who is granted access to it. Your username should have strong passwords that are hard to crack, and each user should be granted access only to what they need. Windows and OS X or Mac OS allow you to create standard users or administrators, and they also include parental controls for child accounts. Okay, so unfortunately I need to pause the recording, and we'll continue in the next one.